Hello viewers, welcome back to the course on matrix computation and its application. So, in the previous lecture we have started with the null space. So, in this lecture we will continue with that one. So, in the previous lecture, we have introduced about the null space of the matrix A, and we know that is a set of all solution of the homogeneous system, and then also we have defined the null space of A transpose, and that is also the y such that A transpose y is equal to 0. And we found that if we have a matrix A that is M cross N, so it has a transformation, linear transformation or linear function from Rn to Rm. So, in this case I know that this is a subspace of Rn and this is subspace of Rm. So, that we have discussed. Now, so I will take one example and then we will go further. So, I just take one example. I have a matrix A, and suppose this matrix I am taking 1, 2, 2, 3, and it is 2, 4, 1, 3 and 3, 6, 1, 4. So, this is the matrix I have taken, and now this is 3 cross 4 matrix. So, I can say that this is a map from R4 to R3. Now, in this case, just to start with this one. Now, so what I want to do, I want to transform the matrix A into the upper triangular matrix echelon form, not the upper triangular, it is because it is a rectangular matrix. So, I want to convert this into the row echelon form. Now, what I want to do is that I want to find out the echelon form, and then with the help of the echelon form I should be able to find all the 4 subspaces associated with the matrix A. So, for this one first we do. So, what I will do is that I will write the matrix A here 1, 2, 2, 3, 2, 4, 1, 3, 3, 6, 1, 4, and here I am taking the unit matrix. So, I have taken this matrix. Now, I call this matrix as A bar. Now, so I want to convert this into the row echelon form. So, first of all I will try to make this element 0 and this element 0. So, I will apply this row operation. So, I will take minus 2 times. So, I am taking here minus 2 R1 plus R2 and minus 3 R1 plus R3. So, from here I will get 1, 2, 2, 3, and this is 1, 0, 0. Now, it becomes 0 here. So, it becomes 0 here. This also becomes 0 because I am multiplying the minus 2. So, minus 4 and minus 2 plus 1. So, minus 2 plus 1 is minus 3, and minus 6 plus 3 minus 3. Similarly, I am doing the calculation here also. So, I am multiplying by minus 2 and add here. So, it will be minus 2, 1, 0. Now, after this, here I am getting 0 because I am multiplying by minus 3 and adding here minus 6. So, this will be also 0. then I am multiplying by minus 3. So, it will be minus 6 plus 1, it will be minus 5, and this is minus 3, and minus 9 plus 4 is minus 5, and here I am getting minus 3. So, I will get minus 3 here, and then 0 and then 1. Now, so this is the way I am getting. So, now I want to eliminate this element. So, this element we have to eliminate. So, I will apply this now in the next one. So, and this is my pivot element. So, this is my pivot and this is also my pivot. So, I will apply now. So, what I am going to do is I will divide R2 by minus 3 and multiply by 5 and add to R3. So, this, so I will get 1, 2, 2, 3, this is 1, 0, 0, and it is 0, 0, minus 3, minus 3, so minus 2, 1, 0, and then here it is 0, 0, 0, this also becomes 0 because it will be divided by minus 3. So, it will be 1 and multiply by 5. So, 5 plus 5 minus 5 is 0, that is same here. So, in this case now it is minus 2 divided by minus 3. So, 2 by 3, it will become 2 by 3 and then multiply by 5 and then add to this one. So, it will be minus 3. So, it is 1 by 3. So, I am writing here 1 by 3 and this is I am getting from 10 by 3. So, now I am taking the 1. So, it will be minus 5 by 3 and this is 1. So, now you can see from here that this is the echelon form. So, now I can write that this is my echelon form. So, it is my U and this is the matrix corresponding to that is P. So, in this case we know that the matrix P A that becomes U. Now, in the matrix also we know that the rank of this matrix is 2. Is coming to, and P is basically a matrix which is using, that is the transformation matrix which is used for pre-multiplication of A that becomes the U. So, it is 1 0 0, it is 2 by 3 minus 1 by 3 0 and 1 by 3 minus 5 by 3 and this is 1. So, this I am getting. Now, the rank of matrix A is 2. So, I can write this as, so I can write this matrix corresponding to the non-zero rows, I call it P1, and this one I can write as P2. So, it becomes, this matrix becomes P1, or maybe I can use some other color. So, I can write this as P1 P2. Now, from here it is very clearly we can see that the range space of the matrix AT, so that will be spanned by the non-zero rows corresponding to, so these are the non-zero rows. So, these are the non-zero rows corresponding to the given matrix, because it is a the row echelon form. So, in this case we can see that this is the non-zero rows, first two. So, I will take the corresponding rows So, it will be 1, 2 to 3. So, span by 1, 2 to 3 and then 2, 4, 1, 3. 2, 4, 1, 3. So, it is a basically span by this one. And of course, it is we have seen that this is a transformation from R4 to R3 and it contains the 4 component. So, definitely it is a subspace of R4. So, that we have taken, and from here, and I also know that the rank is 2. Then the range space of A. So, the range space of A I can write directly from here. Now, if you see from here, then this is my basic column and this is my basic column basically. Not writing here, maybe I will write here. So, this is my pivot and this is my pivot. So, this is a basic column and this is a basic column. So, from here I can say that the range space of A is a span corresponding to the basic column, and that will be 1, 2, 3 and another one will be 2, 1, 1, and these are linearly independent. So, and that is equal to the rank of the matrix, and definitely this belongs to R3. So, now we are able to find the range space of A and range space of A transpose. Now, we want to find out the other subspaces. So, let us write what about the null space of A. So, the null space of A is coming from the again from the non-zero rows. So, this is my echelon form, and using this echelon form, so I can write my corresponding. So, that is equal to the x such that A x equal to 0. So, from here you can write that the corresponding system of equation becomes 1, 2, 2. So, it will be, I can write here that, so x I am taking from R4. So, suppose my x is, so let x is x1, x2, x3, x4. So, I am writing my Ax, and A is, now it is the echelon form. So, basically I am writing A as reduced to in the form of Ux, and Ux is just I am writing. So, it will be x1 plus 2x2 plus 2x3 plus 3x4 equal to 0, and from the last one it is minus 3 minus 3. So, I can write here minus 3x3 minus 3x4 equal to 0. So, I get only these two values. Now, for this one I need to find the, because this is going to have a infinite many solution. So, x2 and x4. Now, the rank is 2. So, rank of matrix A is 2. So, from here I can know that number of free variables will be 4 minus the rank, that is 2. So, it will be 2 free variables. Now, in the 2 free variables here, if you see, then we have to find out 2 variable free. So, we will take the free variable corresponding to the non basic columns. So, here we have, so I can write from the first equation and from the second one. Now, my free variable basic non basic columns are the second and the fourth. So, what I am going to write? I am going to write my x 3 is equal to minus x 4. From this one I can find out, and this one I am finding. Also from the first equation I can write my x 1 is equal to minus 2 x 2 minus 2 x 3 and minus 3 x 4. Now, in this case I can write minus 2 x 2 here. So, x 3 instead of x 3 I can put the minus x 4. So, it will be 2 x 4 minus 3 x 4, and from here, so that I can write as minus 2 x 2 minus x 4. Okay, so from here now I got this one. So, from here I can write my ux. From here my x become x 1, x 2, x 3, x 4, that is equal to. So, instead of x 1 I will write minus 2 x 2 minus x 4. So, it will be minus 2 x 2 minus x 4, and x 2 is x 2, x 3 is minus x 4. So, x 3 is minus x 4 and x 4 is x 4. So, you can see that we are writing each and every variable in terms of x 2 and x 4, and from here I can write that my x 2 can be written as minus 2 1 0 0 plus x 4, it is minus 1 0 minus 1 1. Okay, so we are able to find the x 1 in terms of x 2 x 4 and x 3 in terms of x 4. So, from here now I can write my, so this I can write as a x 2 is a the non basic variable corresponding to h 1. So, this is my h 1 plus x 4, it is my h 2. So, this is the vector we are taking, we represent by x 1, h 1 and h 2. So, now from here I can say that the null space of A is spanned by minus 2 1 0 0 and minus 1 0 minus 1 1. So, this is my null space, and you can see from here that this is from R4 and these are linearly independent. So, I can also write that the nullity is 2. Now, I want to find what about the null space of A transpose. So, in the case of null space of A transpose, the only thing is that it contains all the y's such that A transpose y is equal to 0. So, in this case what we need to do is that we want to find the A transpose, that is basically I get the matrix 1 2 2 3 and then 2 4 2 4 1 3 and then 3 6 1 4. So, this is my matrix, of course, it will be 4 cross 3, and now I have to convert this matrix into the again into the echelon form, and then we have to find out the solution for this one. So, that is we have to do it again. So, let us do this one for this example. Now, my so I want to transfer this matrix into the echelon form. So, what I am going to do is, so this matrix converting to some echelon form V. So, by this one I am writing, so this is my pivot element. So, in this case I am applying this formula. I will apply this elementary transformation minus 2 R1 plus R2 minus 2 R1 plus R3 and minus 3 R1 plus R4, and if I apply this one I will get 1 2 3 0 0 0. So, I am multiplying by minus 2 and adding here. So, it is minus 2 plus 2 0, minus 2 plus 4 it is 0, and minus 6 plus 6 it is 0. Again I am doing this one. So, it will be 0 and minus 2. So, it will be minus 3, and this will be minus 3 into minus 2 minus 6 plus 1. So, it will be minus 5, and again I am multiplying by minus 3. So, minus 3 plus minus 6 plus 3 minus 3 and minus 9 plus 4 minus 5. Now, I will swap my R2 with R4 because the 0 element is there already in this case. So, it is 1 2 3 0 minus 3 minus 5 0 minus 3 minus 5 0 0 0, and from here I will again apply the operation to make this element 0. So, what I am going to do is that I can write minus R2 plus R3. So, it will be 1 2 3 and it will be 0 minus 3 minus 5 0 0 0 0 0. Okay, so, from here you can see that this is my echelon form and this elements are the pivot elements, corresponding pivot elements. Now, I need to find that the null space of the corresponding matrix. So, for in this case I have 1 2 3. So, now null space of A transform, so that we are going to find. So, it will contain the y. So, I will write A transform y, that is basically V y. So, from here I can write the matrix V and y is belongs to R3. Okay, so, my y, suppose I take y1 y2 y3. So, here I can write V y becomes y1 plus 2 y2 plus 3 y3 equal to 0 and minus 3 y2 minus 5 y3 equal to 0, because I am multiplying the y. So, y1 plus 2 y2 plus 3 y3 and minus 3 y2 plus minus 5 y3. Now, in this case also this is my basic columns and this is my non basic column, the last one. So, I can write everything in terms of y3. So, from here you can see that my y2 can be written as minus 5 by 3 y3, and if I put here, then from the first equation my y1 can be written as minus 2 y2 minus 3 y3 and y2 is written here. So, it is minus 2 into minus 5 by 3 y3 minus 3 y3. and this is 10 by 3 minus 3. So, it is y 3 by 3. Now, from here I can get that from here my y basically become, so y 1 is becoming y 3 by 3, y 2 is minus 5 by 3 y 3, and y 3 is y 3. So, it can be written as y 3 1 by 3 minus 5 by 3 and 1. So, I can write from here that the null space of A transpose is spanned by the vector 1 by 3 minus 5 by 3 1, and because it belongs to the R3. So, that is the null space of this one, and we also know that the null space of A transform is also called left hand null space, and this is equal to this one. So, its dimension is 1. Now, from here you can see that it is spanned by the element 1 by 3 minus 5 by 3 1, and for this one we have taken all the transformation. First we have taken the transpose, and then we convert that into the echelon form, and then we are able to find. But if you see from the previous one, and now you can see from here that the P2, so P was the non-singular matrix such that PA becomes U, and in that case we came to know that the first two rows are the non-zero rows in the echelon form, but the last row was the 0 rows. So, it was the 0 row. So, this was my 0 row, and this was my P2 corresponding to the 0 row. Now, from here if you see, the P2 is 1 by 3 minus 5 by 3 and 1. So, from here we are going to introduce one thing, that we can also write that the null space of A transpose can be written as the range space of P2 transpose. What is the P2 transpose? Because if you see from here, P2 is a row vector. So, I just take the column, make it column vector. So, I will take the transpose. So, it means my P2 transpose is basically a column vector which has the element this one, and you know from here that it is spanning this one. So, if I wants to find out what is the range set of P to T, then we know that the range space of P to T, it is a column vector. So, you can take it is a matrix with 3 rows and 1 column, same as we used to find the range space of A or range space of other one. I can find the range space of this one. So, that is equal to set of all P to T x. So, now from here this is my 1 by 3 minus 5 by 3 1, 1 by 3 minus 5 by 3 1. So, this is my P2, and it is 3 cross 1. So, I will take my x, that is 1 cross 1, and from here I will get it become x by 3 minus 5 by 3 into x and x. So, I got this vector, and definitely this will belongs to the range space of P to T, and from here, and this is just one vector. So, it is linearly independent. So, from here I can say that the range space of is spanned by the element the vector 1 by 3 minus 5 by 3 and 1, because x is just a real number. And you know from here that this is coming to the null space of A transpose. It means that there is no need to write the transpose of the given matrix and then converting this into echelon form and then writing the null space of A transpose. So, it can be found directly by the span of the matrix P2 that is coming from this matrix. So, P2 is basically we convert the matrix P into P1 and P2 form and then we found the P2. So, based on this one, now based on this one, from the given matrix A, I have converted this into U by P A is equal to U. Then we are able to write the range space of A by the basic columns corresponding to the columns of in the echelon form. We are able to write range space of A transpose, that is the left hand space, range space. This is coming with the non-zero rows corresponding to the echelon form. We are able to write NA directly because it is just putting the non-zero rows into x equal to 0 and finding this one, and now we are able to find NA transpose, and NA transpose is basically the range space of P2T. So, with the one matrix transformation, I am able to write the complete 4 subspaces associated with the given matrix. So, this is what we can do from this one. So, I think now we stop here. So, today we have discussed one example and showed that using that example or the matrix A, we are able to write all the bases for the basis for the corresponding subspaces associated with the given matrix. So, in the next lecture we will continue with this one. So, thanks for watching. Thanks very much.